let's open up for Q&A if we have any.
Yeah, absolutely. So just want to encourage everybody in the put your questions in the chat. We do have a few questions, so I'll start with those. One question is, what are the services that Power Edison provides for utility industry?
Obviously, what we showed you here is that we build and customize solutions for our customers. But we understand that energy storage, and specifically mobile energy storage, is unique. It is not what you run into every day. It does require unique analyses, tools, understanding of the chemistry, of the mobility, of the bridge laws, of the frost laws, of the trailers, the equipment, safety. So we have been engaged, and we do have a service in-house to work with utility partners. We assist in rate filings, we assist in benefit cost ratio analyses. We've done quite a number of those. Some of them are mentioned publicly by our utility customers and partners. We do engage with commissioners. We do engage with rate advocates in terms of explaining why this is a prudent investment. And this is yet another tool in society, in addition to what we see in terms of private ownership of battery storage. This is another critical tool in society to bring the cost of the electricity system down, shave the peak, reduce greenhouse gases, to increase reliability, to increase safety, to react quickly to market needs. I mean, nowadays, there are all kinds of applications we can talk to about what triggers a major change in the grid. So at Power Edison, we do have a professional services group that engages with the utility sector to work on the cases, but we also manufacture and build the systems, and we ship them.
So we have a couple more questions. So one is, how are public utility commissions viewing mobile energy storage?
It's a good question. And I see that we have some participants on this call from public commissions, so we welcome you. And this is actually, we've had many meetings with commissioners around the country. And they, once they see that this is a prudent investment, at the end of the day, who pays for the electrons when they get delivered? It's the ratepayers. And so sometimes the market design forces certain functions to be performed by entities that, frankly, are not the right entities. So it adds costs, it adds inefficiency, and so on. This is one of the few cases where batteries, private sector obviously has full right to own, and they do, of mobile storage. But this is one of the few cases that you have a very strong case for regulated utilities in owning mobile storage. And there were very actually innovative ideas that came out of some of the regulators we met with. To give you an example, we know that utilities do share in emergency services. If there's an outage in one state or one service area, linemen from one utility can go and assist the other utility with that help. And so commissioners brought up, like, well, can I do the same with a mobile fleet of batteries that a utility owns? And the answer is absolutely yes. If someone has an emergency or hurricane damage, and just like you can move mobile subs, mobile transformers, you can move mobile storage. And effectively, the commission that gives the green light to a utility in their service area to rate base such assets, you want to maximize the use of those assets. So the ratepayers are getting a great value. So that's, for example, a topic that was brought up where such precious assets can be shared by a larger part of society and for the benefit of the ratepayers who help support the purchase.
Thank you. So we have a question. Is there any appetite for mobile charging solution that's coupled with storage?
Yes, that's so I talked earlier about that load growth that would trigger the need for NWA on behalf of utilities and non-wire alternatives. And traditionally, it's the conventional load growth, building a high rise coming up in an area, it's a factory. But about 3 or 4 years ago, as electric vehicles started to become more popular, it became obvious that EVs are a mega trend that is adding to the rapid need for upgrades. So a number of our utility partners saw that certain pockets where maybe a school bus company or a school bought electric buses, and now they need to quickly run a new feeder to that neighborhood. And then they bump into siting, permitting, digging up the street, or putting new poles. And so we saw that EV infrastructure upgrades are being challenged because no one can react quickly. You can react quickly with mobile storage. You can site this, downstream next to the school or next to the fleet, and attend to the need of the EV charging infrastructure. So with that, we not only responded to that market condition, we actually created a sister company, EV Edison, that you mentioned earlier, Kevin. The company we created as a sister company to Power Edison. Power Edison today is 8 years old. EV Edison is just 2.5 or 3 years old. Specifically, so we can understand the technology, we can understand the need, we can understand the design, and advise our utility customers on how EV charging can be addressed and serviced through mobile storage and in combination of the two.
So I'm going to combine, there's a question on cost. So what do projects like this cost? And then I'm just going to combine that with another question is how does the cost compare?
Yeah, so that's a common question, which is how does my mobile storage compare to my stationary storage? It's a good question. Obviously, when you look at the pictures, I'll go back, just stay here. If you look at the left-hand side, you'll see the added cost for mobilizing a battery in a container is adding that trailer and some electrical work. And that it's a small fraction of the cost. Batteries are expensive, as you know. So batteries in a container can be in the millions of dollars. A trailer could be, let's say, $100,000 plus minus, depending on what type of trailer. So it's an incremental change there. If you look at the right-hand side, you'll also see the major building blocks, which need to be on the ground anyway, in terms of inverters, in terms of poles, in terms of switch gear, in terms of transformers, and we integrate them. We also, the mass is fully fabricated by us. We have low voltage control cabinets, wiring, and so on. And there's a trailer that's integrated as part of the solution. So there is an incremental cost to the CapEx. However, there's a significant reduction in the EPC costs in the installation and procurement construction. This is almost like a modular home. You build it at a factory and then you bring it to the site. You just need to perform the electrical connection. But you're not digging up the grounds and providing, cement pads and calling the local inspector every step of the way, or the land is frosted or snowing or raining, you stop the work and you come back. That's all minimized. And so there's a little bit of incremental cost on the CapEx, significant reduction on the installation, and so you come out almost equal from the get-go. However, the minute that mobile storage asset is repurposed once over its lifetime, your benefit cost ratio is ahead of the stationary system. So from the get-go, you're equal. I can say equal, but then the minute you repurpose that, you're way ahead in terms of benefit cost ratio.
So somebody noticed in one of the pictures batteries on a barge and had a question, are there other forms of mobility that storage that Power Edison is working on?
Yes. So let's go back the cover slide. So for us, mobility is mobility, whether it's on wheels. We also have solutions for batteries on barges. We also have solutions designed for batteries on rail. Batteries on barges, we have customer engagements, but we have our own pipeline of battery storage on barges in areas where utility scale batteries need to be constructed, but land is expensive. Okay. I mean, there are obvious places around the country in the US, whether you're in San Francisco, Houston, Miami, New York, Chicago, Boston, you can be at the waterfront areas where you need to bring same case that I mentioned earlier. It could be a T&D deferral, it could be an NWA case. And so by having engineered and developed the batteries on barges, that makes it a very attractive mobile solution. And we do have, in New York, we have a pipeline of such projects under development with the backing of the Department of Energy. We have some what we call Part 1 approval from the DOE LPO program for financial support for deploying battery barges in New York City. We have other locations also where we're considering batteries on barges, especially, like I said, where land is expensive. Land tends to be expensive in downtown areas at the waterfront. And all the benefits we mentioned earlier about mobility apply to the barge. So we have the terrestrial system, we call it TerraCharge, that's the product name, and we have EquiCharge for the one on the water.
So there's a question about application for smaller communities in regards to like leasing batteries, a preferred method versus purchase.
Yeah, so that's, I noticed some of the participants here, some are what we call IOUs, investor-owned utilities, and some are utility participants from public utilities. For example, just to give an example, Con Edison or PSE&G or National Grid are IOUs, investor-owned utilities, or private utilities. They can be publicly listed as part of a parent company, versus, for example, LEDWP in LA that's owned by the city, residents and taxpayers in LA, that's public. The mechanism for procuring assets, frankly, is slightly different. The IOUs owned by the private sector are incentivized to build a rate base, which directly contributes to the financial health of that investment from the private sector. In a public utility, the driver is different. It's almost like, you don't want to overbuild, you want to just, and so kind of you do see distinctions sometimes in terms of the quality and the age of equipment between the two. So we do see cases where people are eager on the assets because that's their core business model. And we do see utilities or communities, could be rural electric, could be co-ops, that would like just to lease it because the CapEx is a challenge upfront. So we do offer both. I mean, if someone wants to purchase the equipment, that's a service that we provide. But if someone wants to lease it or rent it, we also provide that as well.
So I'm again combining a couple of questions into one. But so from work with utilities, can you speak to how grid dynamics have changed over the years, and how does mobile storage address those changes?
Yes, I think kind of similar to what I touched upon earlier. The traditional, and I personally have been working with electric utilities for many years. You mentioned the solar project before in the introduction. That was a project, the largest in the world at the time, that was done with PSE&G, the electric utility in the main electric utility in New Jersey. We've deployed the same in, in Australia and Middle East and Florida and in California with various utilities. So we've been working personally, and my colleagues have been working with utilities for many years. And traditionally, it actually it got to a point where the load growth was becoming negative in some areas, which challenged the core kind of financial health, I'll say, of such utilities. Nowadays, you see mega trends that are in favor of upgrading the grids, and I'll speak to some of those. One is the obvious one I spoke about earlier, which is the electrification for the transportation sector. To give you a quick example, in New Jersey, we have 6 million light-duty vehicles, passenger vehicles. And if each one of them had access to, in your garage, in your neighborhood, at your complex, at your office, of kind of like a dry outlet type of outlet, a 10 kilowatt plug rather than, 110. 10 kilowatt plug will charge a Tesla Model Y over 7 hours because it has, if it's 100%, 70 kilowatt hour battery. So even a 10 kilowatt is not super fantastic. It just does charge overnight. But if you provided a plug for every light duty vehicle in New Jersey, you have 10 kilowatts times 6 million vehicles. That's 60 gigawatt of new connections for electrifying the light duty vehicles alone. New Jersey has a significant medium and heavy duty sector, given the fact that we have Port Newark in New Jersey, we have the Turnpike, we have major highways, 78, 80, where these are major thoroughways that support neighboring states with goods and things like that with interstate commerce. But 60 gigawatts of new load that can happen all at once, by the way, because you can assume all these cars are parked at 2 o'clock in the morning and they're all getting charged. Well, how big is 60 gigawatts? 60 gigawatts, the state of New Jersey peaks at 17. So we spent 100 years building a 17 gigawatt grid. And now just electrifying the light duty vehicles can introduce 60 gigawatts. That's almost 3 times. So EVs are massive driver for grid upgrades. And it can happen very quickly. People in a neighborhood, like I said before, or a school bus company buys a fleet and they immediately need the feeder capacity. That can happen overnight, frankly. And they might not call the utility ahead of time saying, I need the power. Another area that we're seeing, it's more in specific pockets, is some utilities are seeing load growth related to indoor farming in urban areas or outside of urban areas. So those for lighting, indoor lighting and controlled environment agriculture, they do consume a lot. And then if you look at a place like New York City is aspiring to become a zero carbon city. There's a law in New York called Local Law 97. Local Law 97 is mandating buildings of a certain size, so many square footage and higher, to become zero carbon buildings. Electrify the heating system. Don't use gas anymore. Use electric heat. Use electric for cooking instead of using gas. But now you have a city like New York City that is electrifying and electrifying transport. So a utility like Con Ed, which built a grid that was just the size of what the load required, all of a sudden are dealing with mega trends from electrification of the transportation sector, from Local Law 97 impact. We're not even talking about other trends. Some other pockets around the country, they might be seeing, AI data centers or machines or crypto mining. So nowadays we see rapid growth on the grid that requires utilities to react quickly. Otherwise, frankly, the reliability and the safety of the grid can be challenged. So that, like, probably a long answer, but I kind of touched upon some of the mega trends that are happening around the country. And by the way, this can be international as well, where the load is growing and growing faster than typically anticipated.
So we have just about 5 minutes left. I have two last questions for you, and then wanted to just encourage everybody, if you want to continue the conversation, we'll put in the chat a Calendly link as well as our email, and you can contact us and we can set up a discussion. So the first question is for like a smaller concept, let's say 1 megawatt, 2 megawatt hour, would it be possible to install a system in a single trailer to minimize cost?
Yeah. So you can definitely put the batteries and the PCS on one trailer. In especially that scale, 1 megawatt, 2 megawatt hours, you do have to think downstream about the first use case, the second use case. Are you going to add other batteries? Are you not going to add other batteries? What if you want to upgrade the chemistry? So we can do that for sure. We customize any solution as needed. But we do bring the best practices from having developed several use cases and solutions to people as we engage, because they might not be fully aware of, frankly, of additional use cases downstream throughout the life of the asset that might support the separation of the PCS and the battery. But if they need to be on one, by all means, we can do it.
All right, so the final question is, can you clarify how a battery provides service in a utility in a distributed deferral scenario versus a transmission deferral scenario?
So the question is, how do we defer distribution versus transmission?
So yeah, looking on for clarity between the two, distribution versus transmission.
Sure. A common, you can call it understanding or misunderstanding, is that batteries for transmission are different than batteries for distribution. And in fact, they're not. They're just more of them for distribution compared to, more of them for transmission compared to distribution, because the building blocks, transformers, the inverters, even the cells and the modules and the containers are the same. So the solution is modular, you just have more of them. We have looked at transmission deferral cases, and mobility also comes to the rescue in transmission deferral. And I'll just give a very high level example. Let's say one location on the grid needs to be, there's a congestion or there's a relief that's needed. I'll use the summertime, and you need 100 megawatts of energy storage, or 120, let's say, in the summer. And another location needs, say, 120 in the winter, meaning they are complementary in the time. And that it's very common, by the way, around the grid, because look, you take New Jersey, you go down the shore, that's a heavy load in the summertime. Everyone goes to Jersey Shore. But in the wintertime, people go to ski resorts in the northwest part of the state. So you can have almost one state where you need the assets in one location versus another. You can have, let's say, 120 megawatts at one location. And then if, let's say, 40 out of the 120 are mobile, and you keep 80 stationary if you need to, and the other location has 80 stationary, then you can have this 1/3 of the transmission deferral asset be mobile, and you move it from one location to the other. You don't have to move the whole thing. And now, by taking that incremental value to be mobile, you perform transmission deferral 2 locations in 1 year while saving about 30% on the CapEx. So this is just one very high level example. We have many more that we've worked on, and we're happy to discuss that offline.
So we are going to conclude the event. We had actually a great question just come in at the very end, which we don't have time for, but I want to read it, and perhaps it's a webinar in and of itself. And the question is, if the systems are modular, does the supply allow you to be insulated from any cyber attacks when being used and deployed? So if you want to take a couple minutes to speak to that, but that might be another conversation too. But why don't I throw that one at you?
Yeah, I think I know we're coming up to the hour, but we're happy to speak either offline or another webinar to, I'll call it the physical and the cybersecurity that go hand in hand of those systems. And frankly, how modular and mobile systems add to the resilience of the grid and the resilience of the operation. And we can speak to that at length. In the introduction, you spoke about previous work that I've done on the smart grid side. So that's an area that we've done quite a bit of work on.
Great. Well, thank you so much for your time today, Shihab, and thanks everybody for being part of this conversation. And as we said in the beginning, our goal here is to open a conversation, not just to deliver information to you. So please contact us, and let's continue forward. Thank you, everybody.